In this video, we're going to be looking at 1.5 Polynomial Functions and Complex Zeros, Day 3. The main thing that we're going to be looking at and investigating today is going to be polynomial inequalities. So a polynomial inequality is a mathematical statement that relates a polynomial expression as either less than or greater than another polynomial expression. So for example, we see this one right here. We see that polynomial expression is greater than 0. Now you might be saying, but there's not another polynomial expression there. But remember, a constant like 0 is a polynomial expression of degree 0. So we can use sign charts to help us solve our polynomial inequalities when we have just one variable. And graphs are also helpful in providing a visualization to the solutions of a polynomial inequality. So for example, this function that we have here, x to the fourth plus 2x cubed minus 15x squared minus 36x, we see the function here with the zeros clearly indicated at -3, 0, and +4. And a lot of the times, what we will want to know is when is f of x greater than 0 and when is f of x less than 0. So when is the function, this one tells us when is the function positive, and this one tells us when is the function negative. Well, from the graph, we should be able to clearly see we have our positive section here. We're above the x-axis. If we're above the x-axis, we're positive. We have another chunk above the x-axis there, also being positive. And then it dips below and then goes above the x-axis again over here. And so this other portion here is definitely below the x-axis, and we'd be able to state that that one is less than 0. And again, when we're given a graph like this, we can easily see and gauge where are we greater than 0, where are we less than 0, when is the function positive, and when is the function negative. So if we are not given the graph of the function or are not able to use a graphing calculator or anything like that, instead we want to identify the zeros of the function by factoring by whatever method that we can. And those are going to be what we call our critical points, because those are the places and the only places where the graph might possibly change from being positive to negative, because it is through the x-axis or the x-intercepts that the function will cross the x-axis and go from either positive to negative or from negative to positive. And so we're going to build one of these, what we call a sign chart, to identify those intervals. And so we have, let's see, on this one we have four different intervals. So we have from -infinity, so all the way over here, to -3, from -3 to 0, from 0 to 4, and from 4 to infinity. And so what we want to do is we're going to pick some test points within the different intervals that we have based on our zeros, so based on our x-intercepts. And we're going to go ahead and plug those into the function and see what we get. Now this is one that's already been done, but when we plug in -5, and it doesn't have to be -5, it could have been -4, it could have been -6, it could have been -3.5. As long as it is within that interval, it doesn't matter. And so we plug it in and we get that our function is positive, or get a positive result. We then plug in a test value in the next interval. They picked -1 and it came out positive again. We see those positive signs that they have there. And then we pick another test value within the next interval and it came out negative. And then our last interval plugged in +6 and got a positive result. And so that then is able to tell us without the graph, hey, this interval is greater than 0, the function is greater than 0. This interval is greater than 0, the next one is less than 0, and then we have our third one greater than 0. So a sign chart can nicely help us see what is going on with the function and where are we going to be greater than 0, less than 0, when is that happening? Now, within each interval between two adjacent critical points, the graph is either always above the x-axis or always below the x-axis. Thus, finding the critical points of a polynomial inequality plays a fundamental role in solving a polynomial inequality. So, if we were to again ask, when is this function, which we labeled as f of x above, greater than 0, then our solution, as we saw, the interval from -infinity to -3, -3 to 0, and from 4 to infinity. Now, one thing of note is that we had to split up our, just going to highlight that interval again, we had to split up at x equals -3, and that's because this one strictly said greater than 0. And so at -3, f of -3 is equal to 0, not greater than 0. And so when that happens, when we have a strictly greater than or a strictly less than, we will need to split up and not include those x-intercepts. Now, if this said instead greater than or equal to, then I wouldn't need two intervals. I would just do one from -infinity to 0, and that would be fine because at -3 we're equal to 0. And actually, I would then want to include 0 because at 0 f is 0, and that's okay. And so then I would have this interval right here. Let's actually go ahead and write that down underneath. I don't want to completely erase everything here, but so let's go ahead and say for this one, if f of x is greater than or equal to 0, then my interval would have been -infinity to 0 included, so we're including -3 and 0, union 4 included, because 4 is equal to 0, and we're okay, it's part of the inequality, to infinity. And so we include those endpoints. And again, when we do our sign chart, we can use, as I showed right here, open circles or closed circles as appropriate. So we have some steps of solving inequalities. I pretty much went through the whole process, so I'm going to go ahead and just skip these steps. You can review these steps on your own as you go through different problems. But I want to go ahead and jump down to our next problem, which is on the second page. So problem number 1, we have g of x is equal to x minus 1 squared and x minus 2 times x minus 2. We want to find all the values of x for which g of x is less than 0. Now, this means the intervals. We want intervals of x, intervals of the domain. So this is already factored for us, which is nice. So straight from there, we're able to find our zeros. Remember, those zeros are the critical points that we want for our sign chart. And that's going to be x minus 1 is equal to 0, and x minus 2 is equal to 0. So x is equal to 1. Multiplicity of 2 it definitely could help us understand what's going on here, but I'll talk about that in a little bit. And then here we have x equals 2. So we're going to go ahead and build our sign chart. So those are our zeros. Now we're going to go ahead and get a sign chart. Now a sign chart, again, is just a number line. So just get a nice number line going on here. We're going to go ahead and put our two critical points, 1 and 2. So we have three intervals here. Our first interval is from -infinity to 1, from 1 to 2, and from 2 to positive infinity. And so we want to tell which one of these three intervals is going to satisfy our inequality. Now remember, our inequality is when is g of x less than 0. So we want to know when are we negative. All right, so we need to pick a point within each of these intervals. So a number left of 1, I'm just going to go ahead and pick, I'm going to use a different color for my test point. So I'm going to go ahead and pick 0. That's a nice, easy number within that interval. I'm going to pick between these two, maybe just 1.5. That's easy enough. And then over here, maybe 3. Those are going to be my 3 test points. And so we need to go ahead and plug them back into the function. Now, we don't necessarily care entirely about what the actual function value is. We care more about what is the sign. So I'm going to go ahead and plug in 0. So if I plug in 0 into this function, I should have -1 squared times -2. Now -1 squared becomes +1 times -2 gives me a result of -2. So I have a negative value for that interval. That one is negative on that side. All right, so we're going to go ahead and pick, let's see if I can get that, there we go. That looks a little bit better to me. So now we're going to go ahead and click in 1.5. So I have 1.5 minus 1. That should give me 0.5 squared. And then I have 1.5. Let's actually go ahead and write that so we can see a little bit better. 1.5 minus 1 squared and 1.5 minus 2. And could also use our calculator to help us with this if we would like. But this is going to give me, if, again, don't really care what the value is, we just more care about what the sign is. If we look at this, is this going to be positive or negative? Well, I have a positive number, that's going to be positive 0.5 squared. This is going to result in a negative number squared. So then I'm going to have, if I square a positive number, that still is positive, times a negative, my result's going to be negative. So that side is also negative. Again, you can go and find the actual value, but for sign charts, all we really care about is the actual sign of the function. What is it? Is it positive or negative? So I'm going to go ahead and plug in 3. So we have 3 minus 1 squared and 3 minus 2. So let's see, that is going to be a positive squared times a positive. Well, all of those positives are going to result in a positive value. So that is a positive. So these two intervals, we have our answer, but let's go ahead and write it for each interval. So for this first interval, g is less than 0 because we're negative. My second interval is also g is less than 0. And then this one is g is greater than 0 because we're positive. So less than 0 negative, greater than 0 positive. Now it wanted all the values for which g was less than 0. So we can go ahead and write our answer here. G of x is less than 0 for the intervals. Now remember, we are strictly less than, so what can I not include? I can't include 1, so we can draw an open circle, and I can't include 2, also open circle. So my two intervals are going to be negative infinity to 1, not included, union 1 to 2. And that would be my intervals. That would be the answer to this problem. Now, it did ask me to sketch a graph of the function. It's going to be a very basic sketch. In a future lesson, we're going to be doing a much more detailed sketch of the of our polynomials. But for right now, we're just going to kind of base it on the information that we have. 1, we know where our zeros are. We're at positive 1, and positive 2. And we know to the left of 1 we are negative, so we're below the x-axis. To the right of 1 we are below the x-axis as well because we're negative. And then to the right of 2 we're negative, but then to the left of 2 we are positive. So we're going to be above. So hopefully this kind of gives you an idea what's going on. So we have no other zeros, so we're going to have to be coming up to here, bounce off here, and then go through here and go positive. So very basic sketch. And again, that matches with the multiplicities that we talked about. At a multiplicity of 2, an even multiplicity, we see that bouncing off right there. And then a multiplicity of 1, an odd multiplicity, we see that we're crossing straight through. So that definitely matches with the multiplicity and the behavior of the zeros that we've talked about previously. All right, and so that's pretty much how you solve these. I'm going to go ahead and move on to another problem. So let's go ahead and try this one, problem number 2. We're not asked to sketch, we're just asked to solve this. Now, one thing that I will cover in here, so if we need to rewrite the inequality, we want to rewrite it so the zero's on the right side of the inequality. That will just make it a little bit easier for us. So that's what we're going to do for this problem here. So we're going to go ahead and rewrite everything, move things over. So I'm going to go ahead and minus 3x cubed to the other side, minus 3x cubed. I'll go ahead and minus my 9x squared, minus 9x squared. None of these can combine, so we're left with 2x to the 4th minus 3x cubed minus 9x squared, strictly greater than 0. So we're doing a greater than 0 on this one. All right, so this one is not factored for us, so we're going to need to go ahead and factor out. I see an x squared that is in common all the way through, so we're going to go ahead and factor out my x squared. I do not have anything else that can factor, so I'm left with 2x squared minus 3x minus 9 greater than 0. So let's see if we can go ahead and factor this quadratic. If we can't, then we want to go ahead and use the quadratic formula. Now, if we come out with real zeros, then we have zeros. We have some critical points we can use. If we do not come out with real zeros, if we come out with complex zeros, then we would only get our critical points from this factor over here, the x squared. And that's because complex zeros can't be our critical points, just real zeros. So we're going to go ahead and try to factor this polynomial. And so that factors to x minus 3 and 2x plus 3, and I'm going to go ahead and bring down my x squared, and that is greater than 0. So again, we need our zeros, that critical point, so we can set up our sign chart. So we're going to go ahead and take each of these factors and set them equal to 0, each of these. So I have x squared equal to 0, x minus 3 equal to 0, and 2x plus 3 equal to 0. Now here I just take the square root of 0. Well, that just gives me 0. Here I get x equals 3, and here I get x equals, let's see, negative 3 halves, which is equal to negative 1.5. All right, let's go ahead and set up a sign chart then, and let's see what we get. So we have 0 as one of our critical points. We have negative 1.5 as a critical point, and positive 3 as a critical point. So there are my critical points. Those are my zeros, and so we are going to pick numbers within each of those intervals. So I'm going to start over here. Let's do negative 2 looks good. Between negative 1.5 and 0, I'm going to go ahead and pick negative 1. And over here, I'm just going to go ahead and pick 1 for that interval and 4. I usually try to pick smaller numbers, makes it a little bit easier for us. So I'm going to go ahead and plug those in. So we have x, and this one I'll just go ahead and say y. We weren't told if it was f or g. So I'm going to go ahead and plug in negative 2. And I'm going to plug that into my factored form. I find that one a little bit easier when I'm doing this. Now remember, I don't care about the number, but more the sign. We have negative 2 squared, and that's negative 2 minus 3, and 2 times negative 2 plus 3. All right, so that is going to give me let's see, I think this is going to be a little bit easier if I do it vertically. So let's go ahead and do this vertically, y, and then -2 here. All right, so that's going to give me a negative squared is going to give me a positive. Here, that's definitely going to be negative. And from here, that's going to be -4, which is bigger than +3, or well, rather 4 is bigger than 3, so I'm going to end up with a negative there. All that's result is going to come out as positive. Positive times negative, result in positive. So here I have positive, so that means my function is, I'm just going to say f. In this case, f is greater than 0. All right, let's go ahead and do our next one, -1. So I have -1 squared, that's -1 minus 3, and 2 times -1 plus 3. So that's again going to be positive. Here is still negative. And here that's a -2 plus 3, and now that becomes positive. So all that is going to be a negative. So here we are less than 0. All right, let's go ahead and plug in +1, so still positive here. And here we have 1 minus 3, that is still negative. Here I have 2 times 1 plus 3, that's going to result in a positive for sure. So that is also negative, minus f is less than 0. All right, and then our last one, 4. So I have 4 squared, and then 4 minus 3, and 2 times 4 plus 3. And again, just caring about the signs, this one is positive, this one is now positive, and that one is also positive. So all result in a nice positive where f is greater than 0. Now, let's go back and figure out which one did we want greater than 0, less than 0. What was it? And that is right here. We are greater than 0. Now, we can't include the endpoints because we did not have an or equal to. So that's a nice open circle on each of these. So greater than 0 is going to be here and here, it looks like. So we're going to go ahead and say that, I'm just going to go ahead and say answer. Here is going to be the intervals from -infinity to -2, not including 2, union, and then jumping all the way over to 3 to positive infinity. And that would be our answer for that one. All right, we're going to go ahead and do maybe one more. I think I want to go ahead and do one that is a or equal to. So let's see. So this one's not or equal to. This one will be very similar to the one that we just did with that factoring that we ended up with. So you can go ahead and practice problem number 3 on your own. Might do that one. Let me see what else we have. I think actually I want to do problem number 5. Yeah, let's go ahead and do problem number 5. Problem number 6 is already factored, so we can do that. Problem number 2 can factor that quadratic, but I'm going to go ahead and do problem number 5, and that will be the last one for this video. And then the rest of those other 3 problems you can go ahead and practice on your own. So we have h of x is x cubed plus 9x squared plus 18x, and we want to know when is it greater than or equal to 0. We have that or equal to on this one, which we haven't had yet. So x cubed plus 9x squared plus 18x, when is this greater than or equal to 0? Don't have to solve, it's already moved over, unlike that last one where I had to move things over first, so we can go ahead and start factoring. I can see I can factor out an x, leaving me with x squared plus 9x plus 18, and that is greater than or equal to 0. And so we have x, and that looks to be factored to x plus 3 and x plus 6, it looks like. X plus 3, x plus 6. All right, and that is still greater than or equal to 0. So we go ahead and we find our zeros then. x is equal to 0, x plus 3 is equal to 0, and x plus 6 is equal to 0. So we have x is equal to 0, x is equal to negative 3, and x is equal to negative 6. There are our zeros, our critical points right there. All right, so let's go ahead and throw this into a sign chart. So nice, lovely little sign chart right here. We have negative 6, negative 3, and 1. So negative 6, negative 3, and not 1. I think I said 1. I meant 0. So we have 3 intervals that we need to test. So I'm going to go ahead and pick a test point in this interval. Pick negative 7. Here, let's see, maybe negative 5. Here I'm going to do negative 1, and here positive 1. So we're going to go ahead and test each of those. So x and y. So we have negative 7, or actually h of x. I can go ahead and use my function on this one because I have a name, h of x. So I'm going to go ahead and plug it into, I like plugging it in again into that factored form. I recommend that. Makes it a little bit easier to just see the signs without having to worry about calculating. So I have negative 7 plus 3, and negative 7 plus 6. So that is a negative times a negative times a negative. 3 negatives equal a negative. So that one is negative, less than 0. Oh, and one thing before I move too far on, I had that or equal to, so we are going to be including our zeros this time around, including those 3 zeros. Those are going to be part of our solutions. We want those. Okay, let's go ahead and pick our next one, negative 5. So that is negative 5. Negative 5 plus 3, negative 5 plus 6. So this gives us a negative, another negative. That one is actually positive, so that results in a positive number. So that one is greater than 0. So we have part of our solution already. It's right there. All right, next one, negative 1. So I have negative 1 times negative 1 plus 3. And negative 1 plus 6. All right, so let's see. That's negative. That one is positive, and we have a positive. So that results in a nice, lovely negative happening there. And then our last one, positive 1. We have positive 1, 1 plus 3, and 1 plus 6. So that results in a positive times a positive times a positive, resulting in a nice positive value there. So we have our negative, positive, negative, positive. So that is when h is less than 0, h is greater than 0, h is less than 0, h is greater than 0. So we can go ahead and say that, I'm going to use a nice orange here, h of x is greater than or equal to 0 when we have, let's see, greater than 0. That would be from negative 6 to negative 3, but we get to include those this time, so negative 6 to negative 3, and then from 0 to infinity. So union, and again including 0 because that can be equal to 0 this time around, to infinity, and we never include infinity, we use our parentheses. All right, and so that concludes this video of solving polynomial inequalities. Thank you for watching. Have a fantastic day.